Okay, so this is the test review for Chapter 5, and we're just going to go through and see what we can do with this. So the first question says we need to solve this problem, and we're looking at the vendor has hot dogs and bags of potato chips. So I'm going to call the hot dogs H and the potato chips C. I just need some way to identify. I could call them X and Y, but at the end of the day, I've got to identify what X is and what Y is. So for me, I'm just going to use H and C so it's easy to tell. It says a customer buys 2 hot dogs and 2 bags of chips. Now if H is the cost of a hot dog and C is the cost of chips, then I could say that 2H plus 2C equals the cost of that purchase, which is $5.50. So 5.5. Then I look at the second customer who buys 3 hot dogs. So it'd be 3H plus 4C, 4 bags of chips, and that cost them $9.50. Now there's way more than one way to solve this. There's actually 3 options. I could do substitution, elimination, or graph them. I'm going to just choose to do elimination. And the way I'm going to do that, so what we're going to do here is we're going to multiply this equation by a -2 to make -4C, which would go with our regular 4C. So times this by -2, which is going to create -4H minus 4C equals -11. That becomes -H, the C's cancel, equals -1.5. So that means a hot dog is going to cost us $1.50. To find the chips, I'm going to take that hot dog price and put it right up in here. 2 times 1.5 plus 2 times a chip equals 5.5. This is 3, so I'm going to minus 3. And get that 2 chips is $2.50. So a bag of chips would be $1.25. So I have the bag of chips, I have the hot dog, and I have both prices. Okay, we're going to keep working on the same process or same idea using an equation that's already been built for us. If I look at this, I could times the top line by -6. That would cancel the x's. Or I can times the bottom line by -6, and that would cancel the y's. I'm going to go ahead and do the bottom line. Well, if only because that 72 is a lot smaller than the 198. So I'm going to times this by -6, which becomes -72x minus 24y equals, and I'll need my calculator for this one. Got a -6 times 72. It's -432. And of course I bring over my 2x plus 24y equals -198. My y's will cancel. I get -70x equals, this will be a big negative. I'm going to minus 198 to get -630. If I divide by -70, I should get that x equals 9. Now to find my y value, I'm going to take one of these equations. Let's just take this one and say that 12 times my 9 plus 4y equals 72. 12 times 9 is 108, so I'm going to minus 108. And I get 4y equals -36. Dividing by 4, y equals -9. So my final answer, I'll just put it right over here, is 9 for x, -9 for y. Okay, so the same approach is basically used for both of those, and we're going to continue that process here with our third question. We have an XYZ equation, which means we're going to have to do this in layers. I'm going to call this equation number 1, this equation number 2, and this equation number 3. If I look closely, equation number 2 doesn't have a y value, which means that I need to create one more equation that doesn't have a y value. So what I'm going to do right now is combine 1 and 3. But I've got to do it in a certain way so that the y's will cancel. Now if I look at the y's, I've got a 2y and a -y. Well, if I times the top line by 2, that would give me a -2y. So I'm thinking 2 times equation 1 would be 2x minus 2y plus 8z equals 30. And equation number 3 I'm going to leave just the way it is. X plus 2y plus z equals 6. That'll give me 3x, the y's will cancel, plus 9z equals 36. I'm going to call this equation number 4. Now normally we'd repeat this process to create equation number 5 using a different combo over here. But I notice equation 2 doesn't have a y, which means it's already ready to be combined with equation number 4. And if I look closely, I notice that the 3x would cancel the 3x if I were to multiply by -1. So what I'm going to do is I'm going to take equation number 4, I'm going to leave it just the way it is. 3x plus 9z equals 36. I'm going to take equation number 2 and I'm going to times it by -1. Okay, that would make a -3x minus 1z equals -4. The x's should cancel. I get 8z equals 32, meaning that z is 4. Now that I know that z is 4, I can plug that into one of the equations up above to find my x or my y. I'm going to go with equation number 2, which says 3x plus z, which is 4, that's what we just found, equals 4. If I minus 4, it's going to give me that 3x equals 0, so x by default must be 0. So now I know that z is 4, x is 0, and to find y, I'll go back to the top, pick one of my equations that uses y. I'm going to go ahead and pick equation number 3. It does not matter. I really need to pick 1 or 3 because they have y in them. If I take equation 3, it's x, which is 0, plus 2y plus z, which is 4, equals 6. If I minus 4, I get 2y equals 2, so y equals 1. Meaning that my final answer is 0, 1, 4. Alright, so we're going to transition over to question number 4, which is essentially the same thing but multiple choice. I'm going to go ahead and I'm going to solve this as if it wasn't a multiple choice question, but keep in mind that if this is x, y, and z, you should be able to plug those into all 3 equations and confirm if they're correct or not. That doesn't take too long, but it does take some time. So this is going to be equation number 1, equation number 2, and equation number 3. If I'm looking right here, I see the z's. Let me move my hand out of the way. I see the z and the negative z. I like that a lot. So I'm going to go after those to cancel. Equation number 1 and equation number 2, just the way they are. 5x plus 2y plus z equals -11. And 2x minus 3y minus z equals 17. This gives me 7x minus y equals 6, and I'm going to call that equation number 4. I want to cancel z again using a different combo. I notice that equation 2 has a negative z, equation 3 has a positive 2z. I like that the signs are different. So I'm going to take equation number 2 and equation number 3, but equation number 2 I'm going to have to times by 2, making it 4x minus 6y minus 2z equals 34. And don't forget to multiply everything by that 2. Equation 3 was 7x plus y plus 2z equals -4. Gives me 11x minus 5y equals 30, and I'm going to call that equation number 5. I should be able to look at 5 and 4 and look for something that cancels. Right now nothing cancels explicitly, but if I times this negative y by a -5, it would become a positive 5y, and that would cancel with my negative 5y. So I'm going to take equation number 4 times a -5, okay, which would make it -35x plus 5y equals -30, and equation number 5, just the way it is, 11x minus 5y equals 30. This gives me negative 24x equals 0, meaning that x must be 0. So that narrows my choices down to D and A. I just need to find one more of the variables. Well, I know over here, okay, that in this equation I have that y right there. So if I take equation number 4 and I bring 0 up for x, that's 7 times 0 minus y equals 6. Well, that's a 0. That means that y must be negative 6. So right now, I now know that A is going to be my answer. But if I wanted to confirm it, or heaven forbid it wasn't a multiple choice question, I would go back to the original problems way back over here and plug in what I know. Let's take, for instance, this middle line. 2 times 0 minus 3 times negative 6 minus z is 17. Well, that's 0, and this right here is 18. So if I minus 18, that would give me negative z is negative 1. So z must be 1. And there's my final answer. Alright. Alright, so now we're looking at 5 and 6, and these ones are going to require that we use some other method. We can't use strict elimination on either of these, so we're going to have to do substitution. Now for substitution, we have to get one of the letters alone. I think it's pretty easy to get this y alone simply by minusing x. And so y is really negative 17 minus x. That information can go into the other equation where y takes place. That's going to give me x. Instead of y, I'm going to write negative 17 minus x in parentheses, and that should equal 72. I need to clean this up so I can solve it. So if I distribute, I should get negative 17x minus x squared equals 72. This is a quadratic, I can tell because of the x squared, so I want this all equal to 0. So I'm going to move all of this over to the other side by addition. That should give me x squared plus 17x plus 72 equals 0. And this is a quadratic that should factor. Factors of 72 that add up to 17 are going to be 8 and 9. I see that everything's positive here, so I'm going to go plus and plus, meaning that x would equal negative 8 or negative 9. Now I'm supposed to find an xy solution. What I found was that if x could be negative 8 or it could be negative 9, which means each of those needs to be tested to see what the answer would be if I use that as my x value. So I'm just going to do the xy equals 72 to check. If I put negative 8 times y equals 72, that would mean that y would have to be negative 9. So I first have the answer negative 8, negative 9. That's one of them. Then if I put in negative 9 for x, I would get that y would have to be negative 8. So it turns out that I have negative 9 for x, negative 8 for y. So two solutions based on solving for two x's and then plugging both those x's into one of the original problems. You could have also done it right here where x plus y is negative 17. Alright, we keep a cruising. Question number 6, same idea, except that we're going to have to do substitution maybe in a different way. I can either solve this for y and plug it into the top equation, or since y equals all of that stuff, it could go right there where y equals, leaving me with x plus x squared minus 6x plus 9 equals 3. And you can see the y is what's in that parentheses. Now there's no distribution to do, so I'm going to combine all my like terms, and I'm even going to minus 3 from both sides to get x squared minus 5x. Now that's, again, the combination of our like terms. And then 9 minus 3 is plus 6, and that's all equal to 0. Again, we're going to say this is x and x. Factors of 6 that add up to 5 would be 2 and 3. Because the 6 is positive, the signs match. To get a negative 5, it would be minus minus. So x could be 2 or 3. Well, I still have to figure out what the y values are that are associated with that. Now over here we had the equation x plus y equals 3. Well, if I put a 2 in for x, y would be 1. So I have the ordered pair 2, 1. Let me kind of separate that there. And then if I do the 3 for x, then y would be 0. So my second answer would be 3, 0. Okay, so those are my couple of choices. Now we start into the graphing and the inequalities. When we graph inequalities, it's really important that we have y by itself and that y is positive. Now I could move the x and then divide by -1, but I know that requires the sign flip, and I worry some of us forget to do that. I'm a big fan of simply adding y to the other side and kicking the -4 over by whatever switches its sign. So I'm going to add 4 to one side, add y to the other. That should give me x plus 4 is greater than y. So I'm going to go ahead and graph this. Now I can use my calculator, but this is just a line. So I know that you go up 1, 2, 3, 4, put a dot, and then you're supposed to go according to the slope, which is 1 over 1. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. The next thing I need to look at is this a solid or a dotted line? If we look at our inequality sign, it doesn't have an equal to bar underneath it. If we had that bar there, it'd be solid. But as it stands, it's a dotted line. Okay, so there's my line. Now I have to decide, do I shade above it or below it? This is really important. Y is on the less than side of the inequality. Well, the lowest y values I can find are downward. So that's going to tell me to shade below the line. All right. Let's do a parabola. So this one, again, if you know your parabolas, again, put this in the calculator if you're having a hard time. But if not, this is just a standard parabola shifted down 2. So I'm going to come down 2. It'll have dots there and there, over 1, up 3 more. So there's my parabola. Now I have to decide, is it solid or dotted? Again, I look here, is there an equal to bar? And there's not. So this is a dotted graph. And just try to make sure it looks not solid. And then we need to decide, do we shade inside the parabola or outside the parabola? I see this as y is greater than. So it says to shade up. I am always a believer that when you're doing parabolas, you go to the vertex. So if this is the vertex, up is this way, which is inside of the parabola. So I'm going to shade inside the parabola. Okay, if it was down, I would shade on the outside, and that would include even these areas over here. So I say go up or down, it tells you if it's inside or outside. We're down to just a couple of problems, and as we get into this, we may see that I might start using a calculator a little bit more, but so far it hasn't been too bad. Again, we've got to get y alone. So the first thing I'm going to do is minus 2x from both sides. Give me 3y is greater than equal to negative 2x plus 6. And then I need to divide by 3. Do it in each place. Give me y is greater than equal to negative 2/3 x plus 2. Let's start with that graph. I'm going to go up to 2. Okay, and I'm supposed to go down 2 over 3. Now this is a solid line, so I'm going to grab my ruler just so I get a good, nice solid line. And try to connect those the best I can. Now, it's important to note that this y is on the greater than side, so that means we would need to shade upward. So because this is on the greater than side, I'm expecting this to shade upward. Okay, I'm not going to do a ton of shading right now because I'm going to have to shade a couple different parts. Let me grab a couple other colors. But that's just so that I know it's upward, generally speaking. All right, the next one I'm going to do is this. Now I see the y is negative here, so I'm going to add the y over and subtract the 3 back. Okay, that's just Mr. Welch's way of trying to be a little sneaky here. I'm going to have x minus 3 is less than or equal to y. But I notice that y is alone now. So I go down to negative 3, put a dot. And then the slope is 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And there's my line. Now this is also a solid line because it has the inequality bar, the equal to bar. And this one says that y is on the greater than side. So that says we're shading up. So far I can kind of tell there's this angle up here where I'm above the blue line and I'm above the black line. So I kind of like this region in here so far. But I still need to figure out where that third line is. Now, when you have a y or an x without any other variable, that tells me this is either a vertical or a horizontal line. Now, if you're unsure and it's y equals, you can always graph it. But you also have the option to just think, what does it mean for y to be 2? So I'm going to plot some points where I know that y is 2. Y-axis is right here. So y would be 2 here, and here, and here, and here. And pretty soon, I see that it's a horizontal line. So, again, it's an equal to bar right there. So I'm going to go ahead and draw a solid line straight across. Didn't even use a ruler. This one says that y is below or less than 2. So that says to go down. Hopefully now you can see that it's this region right here, this little triangle that we're creating. So I'm going to go ahead and I'm going to shade that nice and solid like that. Alright, our last problem, we're almost done. We have y equals, now this is important that you read this right, this is 3 to the x, okay? And then y is less than 8. Well, we just did a y is less than problem, so I'm actually going to come right up here to 8. I'm going to draw that solid line right across. I know that the graph needs to be below that because it said y was less than or equal to 8, and it's solid because of that. The next thing I need is the exponential. Now, if you're struggling a little bit with your exponentials, we're just going to go in and graph it. Now, it's not hard to graph an exponential by hand, but might as well make sure we have the right idea. We see that it comes along and it takes off. Okay, so we need a couple of points to make that exponential make sense. For instance, 0, 1. I'm going to grab a different color. 0, 1 is right there, and 1 would be at 3. Now we know exponential graphs have a horizontal asymptote, and based on the fact that there's nothing added at the end of the problem, we can assume it's right at 0. With an equal to bar, we know that it's going to be a solid line. I'm going to keep coming up, and it crosses somewhere around there. This one says that y is greater than, so y is above. And I hope you can see that the region where both of them are saying yes is this region here. And that is it. Good luck, and we'll see you in class.